Okay, grade nines. Listen, we talked a lot about light yesterday, and yeah, there's a couple things that the other cohort did at home that you didn't get a chance to do yet, so I want to just cover that with you. I gave you this handout already, so just please take a look at the handouts I gave you yesterday, and we're just going to fill it in. I'm going to go through kind of quickly, but you can like pause this and write it down, whatever. Okay, so let's look at reflection of light. Okay, so today we were looking at the different types of luminescence and everything in class, and there was the chemiluminescence and bioluminescence, and electroluminescence, triboluminescence, and so on. So that's the way that light is created and everything else. And we looked at that, and there's a couple of questions on that sheet that I'd like you to do. On this sheet, it's pretty straightforward. Okay, so we're just going to look at the law of reflection, and the law of reflection is very simple. Okay, when light hits something and bounces off, it obeys this law. So here comes I'll just sort of squiggle in. Here comes a beam of light. Boom, it hits the mirror down here, and it bounces off like that. Now, if you measure these two angles, we measure from what's called a normal line, which is an imaginary line, this dotted line down here that I've dotted in red down the middle. It's perpendicular to the mirror, and in math, the word normal means perpendicular. Okay, so that's why we call it a normal line. If we measure the angle of incidence from that line, we call this angle theta I, that's a little weird Greek letter there for you. The angle of reflection that's measured on the other side of the normal line will be the same exact number. Okay, so in other words, if this angle was like 30 degrees coming in, it would have to be 30 degrees coming out. If it were some other number, if it was 35 degrees coming in, then it would have to be 35 degrees bouncing off. These two angles must be equal all the time. Okay, and that is the law of reflection in a nutshell. Now I've wrote it down for you here. The angle of incidence equals the angle of reflection. Now in math and science, we tend to use theta to represent angles. It doesn't have to. It's a Greek letter. It could represent whatever we want. But in our case, we're just going to use it to represent angles. Okay? So that's it. Now, there's actually two kinds of reflection. Now, this is kind of cool. Okay? If you have a flat or plain smooth surface, in other words, let's say you have a really smooth, like piece of plastic or something, then what happens is the light will reflect the incident rays, the surface will reflect, the incident rays along parallel lines. Now this will allow you to see your reflection in that substance. So let's say you go out to the water and it's very still water. Well, that makes a very flat surface, and then you can see your reflection in it, right? So we call this specular reflection. So this word, specular. Okay, it's kind of cool. It's like spectacular without the tack. Specular. So specular reflection. Now, example include polished floors. Okay, so like if you look at the wood floor in the gym, it's polished hardwood. That you can see specular reflections in that. Okay, you have to look for it though. A pane of glass. Okay, you can see a reflection of pane of glass in still water, in mirrors, of course, plain glass, and so on. Okay, so specular reflection, it's a perfectly flat surface. So here, I've drawn it down here. Here's our flat surface. I'm just going to highlight it. And the light, the blue rays of light reflect. I'm not saying they change color or anything. I'm just showing you blue is the incident rays, and red is the reflected rays here. So this is the incident light. This is the reflection on this side. Okay, and then what happens is you get the very nice regular reflection, and that allows you to see your reflection. Now, if you have a rough surface, and I'm not trying to offend anyone, but like let's look at your skin for a moment. Now, there's a reason why you can't see. You might think your skin is very smooth to the touch, but actually it's, microscopically speaking, a rough surface. So it might feel smooth, but your fingers are not exactly good measures of what's smooth and what isn't smooth. And so, and neither is your eyeball, quite frankly. It might appear smooth too, but the appearances can be deceiving. You can't see your reflection in it, so it's not a microscopically smooth surface. Now, what happens when light strikes an irregular surface like your skin or a piece of wood or something like that, what happens is the light gets reflected. It still obeys the law of reflection. It's just that the angle that it's hitting varies according to the surface angle here, and that surface angle is changing all the time with these rough surfaces, and the reflection ends up being diffuse. This word diffuse, I wrote it down here. I should write it again, that looks terrible. It looks like diffuse. Somebody fix it. It's diffuse. Okay, diffuse reflection. And that's typical of surfaces that are that you can't see your reflection in, you know? So let's say the wall. You probably can't see your reflection off of a regular piece of drywall. That's because the surface is microscopically speaking rough. Okay? And that's it. Okay? Specular versus diffuse reflection. Now, oh yeah, I was going to say this. Sometimes when the road becomes wet, like a road is a rough surface, the asphalt, and normally you get diffuse reflection, okay? And that's what you see here in this first image that I circled. But when the road is wet, you can get glare off the road is when it becomes specular. So this is a specular reflection here. And we don't like that on the road surface because we don't want the road to be, you know, brightly reflecting the sun, and then it's hard to drive. And so we usually design our roads so that the water will run off into the storm drains and stuff like that when it's raining. But that doesn't mean you'll never get a specular reflection. Sometimes you do, okay? And you get a bright reflection off of the road surface. All right. Now, images formed in a plane mirror. Okay. Now, what I did was I you know, took some volunteers here from the other cohort. Okay, I made these pictures. We'll get to that in a second. But just take a look. When we have Bridget down here at the bottom, this Bridget. Hey, Bridget, there she is. Okay. She is looking, she's not really looking in this direction, but she's looking at a mirror. Okay. And the mirror is this thing here, this line. This is a mirror over here. Okay. Now, Robin, you recognize Robin from the other cohort. Robin is standing in front of the mirror. Her face is, at least her head here, okay, is in front of the mirror. And she's looking in the mirror and she sees a inverted image of herself. Not upside down inverted, but laterally inverted, right? The left and right are switched. So, you know, she had some writing on her shirt, like, say, like, I love Mr. Flynn's class, you know, like on her shirt. It's normally what she would, of course, have on her shirt, something like that. It would be backwards in the mirror. Now, if she's really clever, she'll also have the written backwards so that when she's looking in the mirror, she can remind herself that that's what it says, right? But yeah, so you can see that her face is actually laterally inverted in this image. So left and right are switched, like she's sort of leaning in on her right side, okay, on the on her left side, sorry, on the actual image, actual person here. This is sort of the left side of her cheek on this side. And over here it's switched, it's on the other side. Okay, now it's on her right side, technically in the mirror image. And you know this when you look in a mirror. Your left and right hand are inverted, right? Okay, and that's how mirrors work. Plane mirrors, at least, the flat mirrors, right, that we're used to looking at in the bathroom and stuff like that. All right, so there you have it, and Bridget is looking at the reflection. Now here's the deal. We know that light obeys the law of reflection, so we know that these two angles will be equal here, the angle of incidence and the angle of reflection. And what Bridget is really looking at is a ray of light that came off of Robin's nose, okay, in this case, reflected off the mirror, okay, and then travel into Bridget's eye. But Bridget will assume, her brain will assume that this light traveled along a straight line, and she actually is looking at an image of Robin's nose that I just sort of put a dot on it over there. Okay, so she's looking at that image that seems to be behind the mirror. Okay, so we call this a virtual image. I'll explain why later. Whoops. A virtual image, and that's it. Okay, now there you go. So that is image formed in a plane mirror. And what are the characteristics of this image? Well, these images have 4 characteristics, and I use this acronym SALT to remember them. And like I said here, I don't mean Robin is salty, okay? I'm not trying to be mean to Robin. She's, I'm sure, a very nice person, okay, from what I've seen. But anyway, the S stands for size, so how big is the image? Attitude doesn't mean whether she's mean or nice or anything. It means, like, is she inverted or not, okay? Location is where is the image, in this case behind the mirror. And type, there's only 2 possible types of images. They could be real images or virtual images. Now, virtual has this unfortunate connotation in the modern world. It means like it's inside a computer or something. That's not what we mean here, okay? A virtual image cannot be projected onto a screen. So this image here, if I were to put a screen, like a projector screen or something, here where I see this image, I will not actually see Robin's face in that screen, because it's not that the image isn't really behind the mirror. It just appears like it is. Okay, so a real image can be projected onto a screen. So images coming from lenses and some curved mirrors, they can actually be projected onto a screen, and you can see, okay, the image of that object. You'll see when we do the candle lab what I mean by this, but that's the definition of a real image. A real image can be projected onto a screen, so my projectors produce real images, okay, of the computer screen, and they're projected on a wall. A virtual image, though, cannot be projected onto a screen, and images behind a mirror are examples of that. If I put a screen behind the mirror, obviously there's no image behind the mirror. The mirror is this opaque object. It only appears as though the image is behind there. That's why we call it virtual. All right, so what are the 4 characteristics of Robin in this particular example? Well, when you're looking at yourself in the mirror, what is the size of the image that you see? So if you're looking in a flat mirror, you are the same size. So the size could be bigger, smaller, or same size. And a plane mirror meaning the flat mirror that Robin is using here, you're going to look the same size, okay? Now, attitude. Attitude is either upright or inverted. So in other words, is anything inverted in the picture? So this is the question. And the thing is yes, you're not inverted in the sense that you're not upside down. So you're not vertically inverted, but you're laterally inverted, okay? You're vertically normal, but laterally inverted. So text on your shirt will appear backwards, stuff like that. That is a lateral inversion. Now, location. Where is this image? Well, in a plane mirror, the image seems to be behind the mirror itself, like behind the glass of the mirror. It's like you're inside the mirror, kind of. Well, yeah, that's where it appears. There's no real image there, but the virtual image appears to be behind the mirror. Now, type. Okay, this is the last category for the properties of the image. It could be real or virtual. So when you're using a plane mirror, okay, like remember, real means it can be projected on a screen, and virtual, you have to look through the device, through the mirror in this case, to see it. You can't use a screen. If that's the case, then it's virtual. So plane mirrors have virtual images. The images appear behind the mirror, but if we put a screen back there, we will not be able to project the image back there. So you have to look through the mirror to see the image, okay? And that's it for this handout, okay? So put that one aside. You're welcome for helping you with that. I know that, that was a big job. Okay, this activity here, we're going to skip it for now. Okay, the mirror activity, we'll do it in class because you need the mirrors, and we didn't have time to do it, and that's not a typo. It's not mirror activity, it's mirror. So we'll do it when we get the mirrors tomorrow. Oh, my kids are playing in the band here. I feel like joining them. Okay. All right, so there's the deal. You've got your worksheet here. Put it aside. We'll work on it together the next time I see you, which will be on Friday. Okay. Don't forget Friday's a dress down day. Okay, Friday's a dress down day, except for Sarah Fauteux. It's not a dress down day for her. She's already had her dress down days. Okay, now I do have another activity for you, however, and I'm going to ask if you could print this. Okay, now I'm sorry I didn't give you the printout today. I gave you a lot of handouts today. I'm sorry for that. But here's the deal, okay? What I'm going to do is I'm going to go through some of this with you. The next thing we're going to be doing is working with curved mirrors. Okay, so here, let me label, here's the curved mirror. I'm going to color it blue for you. This little thing here. Okay, that surface that I'm coloring in this pretty blue color, that is a curved mirror. Okay, and it's got the lines behind it. Mirrors are opaque, you can't see through them, right? You only see reflections in them. So we call this a parabolic reflector. In this case, it's just a curved mirror, that's what we call it. Now, this thing, by the way, you're seeing here is a ray of light. Okay, I should color it red. So here's a ray of light coming in this direction. That's what the arrow is indicating. It hits this mirror. It obeys the law of reflection because there's a normal line. Okay, and then it reflects down here like this, that way. Okay. All right, so a curved mirror. How does that work? Well, first let's label this picture. So I'm going to go to black ink here. Okay, so you're supposed to label these 7 items that you see up here, and there's a little arrow that goes with each one. So first, the center of curvature. Where is the center of curvature of this mirror? That's where, like, the mirror makes a little circular arc. Where is the center of that circular arc? And it's actually over here. Okay, so that's number 1 right there. That little line, that little dot, is the center of curvature of, in other words, like if I were to draw a circle using like some type of tool, where I put something like a pin or something in the center here, and then I draw a little circular arc, this mirror would be part of it. Okay, so that's what we mean by center of curvature. Now the focal point of the mirror is this one here. Okay, it's this, that is the focal point. Sometimes we label it F, okay, for focal point. So that's it right there. We're here. Let me put a green dot on it. This green dot is the focal point. And here, I'll put my little green F here. That's how you label the focal point. So that is on our list, item number 2. Okay, so we've done this one. We've done this one. Now the incident ray of light is this red light here that you see coming in. So this is, pardon me, I should have just labeled it here. This is number 3. That is the incident ray. You don't have to write this, but I'm just trying to help you out here. So that is the incident ray. It's coming in, it's about to hit the mirror. Now, the principal axis is this weird imaginary line here. I'm going to highlight it in rainbow color. This, where you see the focal point right on the line, this weird imaginary line here, okay, that I've just colored in with the rainbow, that whole line is called the principal axis, and that is number 4. So let me label that 4. Whoops, I thought I changed color. There, so that's number 4. All right, moving right along. The reflected ray. Well, clearly the one that bounced off the mirror. Okay, that's this little guy here. That is the reflected ray. Okay. That's number 5. So we did this one, we did this one. Okay, number 6, the vertex. The vertex is right here where the mirror touches the principal axis. So this line is the principal axis. Okay. Wait, no, why did I put brackets? Whatever. This is the principal axis. Now, here is the center of curvature. So, sorry, not the center of curvature. This is the vertex, V. So this is 6. Right there is where the vertex is. I'll just put a little V. That's where the vertex is. Where the mirror touches the principal axis. That's the definition of vertex. Now, the virtual ray is the one that goes into the mirror. It seems to go behind the mirror here. So number 7, that's the virtual ray. All right, so curved mirrors. Now we already know the 4 characteristics of the image. It's salt. I'm going to let you fill that in based on the last sheet that we did. Size, I'll say it, but I won't write it. Size, attitude, location, and type. Okay? Now, it says here, what are the first 3 rules for drawing images in concave mirrors? Okay, for drawing rays. Well, actually, I'll just tell you the rules. In fact, I'll show you the rules, because right here we can see one of the rules. This ray that's going parallel to the principal axis, okay, this red light, it hits the mirror and goes through the focal point. That's rule number 1. Okay, so a ray parallel to the principal axis, okay, reflects through the focal point. Okay, very good. You're so good. You're writing this down. Okay, excellent. Okay, I highly recommend you print it first, so that would be helpful. Anyway, rule number 1. Rule number 2. Okay, and rule number 2 is like the exact opposite of rule number 1. Okay, a ray through F reflects parallel to the principal axis. Okay, that's rule number 2. So if I were to show you that rule, I'm gonna show you rule number 2 in blue. Okay, so a ray that is, I'm gonna start all my rays here at the top. So let's see if I can do this. I should do this with a ruler, by the way, with a straight line, but I can't do that with this Smart or OneNote. So a ray that goes through that focal point will reflect so that it goes parallel to the principal axis like this. Okay, and so here comes a ray of light. This is the origin of our rays of light right here. That's the thing we're looking at in the mirror, if you like. What's happening is that ray, as it goes through the focal point, it reflects parallel to the principal axis. Now, there is one more rule. I haven't drawn this particularly well, but anyway, there is one more rule that we can draw here. There's actually a couple more rules. Okay. Pardon me, my son is banging on his drum over there. Okay, now there's one more rule, and the rule is a ray. Oh, I'm sorry. A ray through. That was awful. Through this the center of curvature C reflects straight back on itself. Okay, and that is rule number 3. Okay, so let me show you that, and I'm going to color this one green. So a ray that goes through the center of curvature here, like this. Okay, so here it is coming from our same source, will reflect once it hits the mirror down here. And this is awful, you really need to use a straight ruler. So I need to continue my mirror a little, it's not big enough. Okay, the mirror would continue like this. So it'll reflect straight back, so it'll actually bounce. The green ray comes in this direction, and when it bounces back, it's going to bounce back along the same line. I guess I'll stick with green again. So it's going to bounce back like this. So in other words, it actually just goes straight back against itself, bouncing off the mirror because it's hitting it perpendicular. Okay? And that's it. Those are your 3 rules. So you see, the red one is rule number, this is rule 1. Okay? The blue one is rule 2. And the green one is rule 3. Okay? So we have 3 rules. 1 I've colored red. That was already sort of drawn on there. 1 I've colored blue, and 1 I've colored green. Okay, and those are 3 rules for drawing ray diagrams. Okay, so that's it. Now, can you draw diagrams, okay, to locate an image? Now, I'm just going to point out something to you. This is F, and this is the center of curvature here. By the way, there is a 4th rule, but the 4th rule is hard to draw, so I'm not going to bother. 4th rule is the ray that hits the vertex just obeys the law of reflection as you would expect. So it's just like hitting a flat mirror there. But that one's hard to draw, so let's not bother with it. Okay, now I'm going to do my best to draw straight lines here. So I'm going to try using the tools, even though I know it's going to fail miserably, but I'll try because it's worth trying for you. Okay, so here's the deal. Rule number 1. Okay, so here, notice this thing. Before I do the rules, here, I want to show you something. I'm going to put a little rainbow at the top of this. This weird looking arrow here, I'm going to put a little dot at the top. This is my object. Okay? Sorry, let me fix that. Okay, that's the thing I'm gonna look at it in the mirror. Now I'm gonna draw 3 rays coming from the object. The rays must come from the top of the object, all 3 rays. So, rule number 1, okay? Rule number 1, pay attention. A ray that is parallel to the principal axis. I don't know if this will work. Oh, it kind of worked. All right, let me see if I can fix that. So a ray that's parallel to the principal axis. Can I fix this? Will it let me? Oh, shoot. Let me see if I can use my mouse and keyboard to fix it. I'm using the pen, but maybe my mouse will fix it. Oh, I'm surprised it actually kind of worked. Okay, a ray that's parallel to the principal axis. So here comes my ray. Okay, it'll hit the mirror like this. And that, according to rule number 1, that's going to reflect. Let's see if I can do this. It's going to reflect through the focal point. Oh, look at this. I almost got it. That's so close. Okay. There. Beautiful. It kind of worked. Okay, so a ray that is, it's not exact, okay? Like this should be hitting the mirror. Oh, maybe it'll let me. Maybe it'll let me. Oh, it kind of does. Wow, guys, I'm so kind of happy with that. That is not bad. Okay, that's rule number 1. That ray that I just drew, wow, I am impressed. It let me do it. Now you need to use a ruler. Okay, so a ray that is parallel to the principal axis. So this is rule 1. Okay, a ray parallel. Just a moment. Sound effects from my boys. A ray that's parallel to the principal axis goes through the focal point. Lovely. Okay, rule number 2. It's the opposite rule. So, rule number 2 is a ray that is going through the focal point. It reflects parallel to the principal axis. If you like, it's the opposite rule. So now I have to start this ray from exactly the same spot. It's not exact, but it's the best I can do. It has to go through the focal point. Now if I can get that to go. There. Okay. Not bad. Now let me zoom in. Let's see if I can just tweak this. So I got to move this so it's right there. Let me zoom out. See if I can sort of get that to make sure it's going actually through the focal point. It's actually not bad. Those two rays should cross at the focal point. Okay. I'm probably not going to get much better than that. So that's pretty good. I could do better with a ruler. Like, you'll have an easier time with this on a piece of paper and a ruler. Okay, you can see I'm a little off with my rays. Let me see if I can fix these ones now that I've zoomed in a little. So this guy, all right, that's not bad. Okay. Well, there you have it. Now, I haven't finished it. So a rule that goes through the focal point, the ray that goes through the focal point, pardon me, it's going to reflect parallel to the principal axis. So I draw another line at this point on the mirror here, okay, and it has to start right here and go straight across parallel to the principal axis. Okay, not bad. All right, now that's rule number 2. So this is rule 2. Okay, so rule number 1, rule number 2. Now rule number 3. Rule number 3 is a ray that is going through the center, the optical center of the mirror, or the center of curvature, which is right here, that black dot is. That just bounces straight back along itself. So this one's really easy to draw. Let's see if I can get it perfect. Okay, now I need to start my ray at exactly the spot where I started these other 2 rays. All right, now if it goes through here, if I've done it right, it should, the 3 rays should meet. Yeah, and they do. Perfect. Oh, that's lovely. Okay. I'm surprised this worked, to be honest with you, because the OneNote software is notorious for not working well under these circumstances. Okay, so here's the deal. That one is rule 3. Okay. Now, I guess I could color them, right? Like, if you like, I could do rule 1. So this ray here is rule 1, and it bounces through this way. Okay, so that red one is rule number 1. Okay, I don't like coloring it, you know, like too much there, because it's just freehand and it doesn't look very good. Rule number 2 is this blue one here that comes down here like that. Oh, pardon me. Comes down here like that, strikes the mirror and bounces off in this direction here. That's rule number 2. Okay, and then finally, I want to color the whole thing in. I'm doing the coloring freehand, so it doesn't work out so great. Anyway, rule number 3, I'll do green. So this green ray goes through the center of curvature, and all it does is bounce right back on itself, so I don't really see the reflection, but it's bouncing just straight back in that direction. And anyway, these 3 rays meet right here. Okay, so where the 3 reflections meet, this is key. It has to be the reflections, not the incident ray. So we're not looking at this focal point here where 2 of the rays happen to be passing through. I'm going to color it in with a rainbow. This point here is where the 3 reflections meet, and that's where our image will form. Okay, so our image, and I'll use the rainbow, is actually going to be upside down right there. That thing that I just drew, this little arrow, okay, is an image. It's an image of this arrow here. Okay, so I'm going to circle it for it. There's the object, and here, this upside down arrow is the image of that object. Now the image is in front of the mirror, not behind it, like we saw you know, with Robin and Bridget, right, where Robin's image was behind the mirror. In this case, the image is actually forming in front of it, and you can find the image by just finding where the reflections meet. Okay, so that's it. They meet right there, and look at how small that little image is. It's upside down. It always starts on the principal axis, by the way, and since it's pointing down below it, we know the image will be upside down. Okay, so here's the right side up arrow. I'm going to extend it a little. So arrow needs to start all the way up there because like I kind of drew it like my ray is too high. But that's it. Okay, now look at the image. Let's write down its characteristics. First, its S stands for size. It's definitely smaller than the object. Look how small it is compared to the original arrow. Let's wait for my screen to refresh. It's much, much smaller, right? Okay. Its attitude is inverted. It's inverted because it's upside down. Right? Its location is in front of the mirror. I'm just going to say between C and F, in front of the mirror. And its type, because it's in front of the mirror and not behind the mirror, it's a real image. In other words, I could put a screen there and the image would be focused and projected onto that screen. So it's a real image, okay? And the reason why we know it is because it's in front of the mirror and not behind it, like normally you would see in a mirror. And that's it, okay? So those are your, that's how you find an image. Now I'm going to do another one for you. That's a bit tricky. Okay, I'm going to let you, here, let's, yeah, okay. Let's do one more, and then I'm going to let you try to finish it. It's tricky though, okay? You might need like to sort of work it out, but we're gonna do this here today, and then I'm going to show you one more, and then we'll end there. Okay, so here's the deal. What about this one? Can we do this now with a second image, second object? So this is our object. Let's see if we can do the rules. So let me use the straight line tool in OneNote. Again, you would do this on paper with a ruler. And if you don't have a printer at home, don't worry, you can print it out later. Just follow along for now. I'll give you a copy at school. Wow, that's awful. Okay, so here. Let's do rule number 1. A ray that is parallel to the principal axis. Now I want to line this up with the top of my object if I can. It won't let me. It's so dumb. Okay. All right then. Well, here, no, I need to get the length right. So let me fix the length of this thing. See, why isn't it working? This is what I expected. This is what I expected it to do, honestly. Let me delete that. Let me zoom in. Okay, so rule number 1. A ray, so let me start my ray right here. It doesn't want to do it. Okay, so a ray that is parallel to the principal axis. Okay, and let's see if can I move that around at least? All right, let's see if it'll let me make it a little shorter. Okay, at least that's the right length. Let's see if I can lower the whole line a little. Okay, I'm going to do this. Okay, it does let me kind of move it. Sorry it's taking so long. With a ruler, how much easier would this be with a ruler, you know? Okay, rule number 1. A ray that is parallel to the principal axis will reflect through the focal point. So, another line, it's going to bounce. See if it'll let me give some smooth variations here. All right, ray through the focal point. Rule number 1, finished. Rule number 2 is its opposite. Now, by the way, here's the center of curvature back here. Rule number 2 is the opposite rule. So a ray through the focal point. Again, it probably won't let me start here. Oh, it did. Oh, wonders never cease. Okay, so a ray that's through the focal point. Let's see if I can get it just right. Right there looks good. So a ray through the focal point gets reflected parallel to the principal axis. So let me again draw one last line to show the reflection of this ray. So it's going to start here, and it's going to bounce straight, straight back. I'm a little off, unfortunately. It's because my object's location is slightly off. Okay, so this should be somewhere like, should be something like this. I'm sorry, everything's slightly off, but you get the idea. Okay, so where's my image? Well, by the way, I can't do rule number 3. It's not possible. This is rule 1. This one is rule 2. But rule 3 says a ray going through the center just bounces straight back, but that would be straight down. The object is on the center, so I'm not able to do it. But I found my image anyway. All I need is the 2 rules. It's right there. In other words, like it's right underneath my object. So remember, okay, this is going to seem strange because we've never done this before. Finding images, okay, but it's fun. I like this. So look, this blue thing is my object, this blue arrow. This rainbow thing is the image of that object, okay, and it's this time right underneath it. So we use just 2 rules to get it. So here, size. The size is the same this time. Wow, I pick a black pen. That doesn't want to change it. Same size, okay? Its location is at C. It's right underneath the object, right? The attitude is inverted again. And the type, it's still real because it's still in front of the mirror. And that's it. Okay, now I'm gonna let you do letter C. Okay, so you do that one. And then I want to show you how you do the last one. I'm going to let you do all the rest, but I want to show you how you do the last one. Okay? So the very last one, this one's weird. Okay? Now, here's how it goes. Rule number 1. We can still do rule number 1, so let's go ahead and do it. Rule number 1 is a ray that is parallel to the principal axis. So let's go ahead and get an arrow. Let's start it right here. I'll fix it in a moment. Okay, so let me move that so it's in the right spot. Give me a break here. That's lovely. Okay, let me zoom out. Maybe I can, if I zoom out, it'll let me move it to the right spot. Okay, let me try moving the end. There. Oh. Okay. Let me now move the other end. Come on, give me control of this. Okay, a ray parallel to the principal axis. Where does it go? Well, it goes through F. Okay, so we take our little line tool. You would use a ruler. Okay, I'm gonna have to fix this in a moment. Alright, so here. Oh, that's actually pretty good. And I'm gonna extend this a little. Okay. We can go as far as we want. All right, that is rule number 1. Okay, I hope everyone sees that. It's always the same rule. Rule number 1. Rule number 2. Okay. Rule number 2. It's a bit hard to do rule number 2, right? Okay, so here's the trick that we use. a ray that goes through the focal point reflects parallel to the principal axis. Well, we can't really do that rule exactly here, but there's a little trick you can use. Okay, and I'm going to do this freehand because it's a little hard to do it using these tools. But you go like this. A ray that would have gone through the focal point. So I just joined the top of my object with the focal point here. And then I'm going to make it solid after that. So now I'm going to draw an actual solid arrow. So a ray that sort of virtually went through the focal point, didn't really go through the focal point because it went towards the mirror from the object. That ray will reflect parallel to the principal axis. Now you don't want to do it freehand like I just did. You want to use a ruler. I'll use the tool for this. So what I'll do is I'll just draw my arrow. Hopefully it'll let me do this. That one will go parallel to the principal axis, okay, out here in this direction like that. Okay. Now, by the way, rule number 3 is a ray that's through the center, so that's this one, will reflect parallel to the, will just bounce straight back on itself. So let me see if I can do that. It's going to have to do a virtual ray again. So this virtual ray that's sort of coming up from the center, that one is going to go like, you know, up here like this, basically. I'm not drawing it. I'm doing a terrible job drawing this. That one just bounces back on itself. Okay. Now, these rays don't meet in front of the mirror. Obviously. Like, look, they don't meet. Like, they're just going to separate. Okay. So, what I have to do to find out where they actually meet is draw virtual rays. So you'll see they're going to meet behind the mirror this time. So this is sort of like Robin's picture in the mirror. So watch what happens. This is cool. So now let's see if I have shapes. Do I have a dotted line shape? I don't. Okay, so what I'll do is I will draw the dotted lines myself, just freehand. You would use a ruler to do this. So here's what I'm doing. I'm going to zoom in on this picture. This ray here from rule number 1, I'm going to backtrack that ray into the mirror like this. Okay, so that's this ray here. It's rule number 1. I'm going to color it. What color did I color before? I think I colored it red. So this is from rule number 1. Okay, what I'm doing is I'm back tracing this reflected ray here, okay, behind the mirror. Now, rule number 2, that's this one here. I'm going to color it blue, okay. If I backtrack this ray, okay, I found a point where the virtual rays meet right there. Now, if I've done my job correctly, and I haven't, I got to be honest here, this last ray should meet they always meet in the same place. Okay, so like if I did it actually towards the center using a ruler, I would have got that. And see, this is the point of intersection right there. So this is where my image is. So again, I'll use my rainbow color. There is my image. It's behind the mirror. Okay, so here, because it's behind the mirror, it's virtual. Oops. I was going to write VR. It's not VR. It's a virtual image. Let me fix that. So that is a virtual image. It's also up. In other words, the object is right here, okay, and the image is right up, so it's not inverted this time. So when I have to my rays like this, whoops, I'm sorry. There's a lot of lag on my computer. I have no idea why. It just does this sometimes when I'm recording. So here, if I were to write down the characteristics of that image, just look at the image there for a moment. Okay, if it ever shows up. Okay, so first of all, the image is larger. Okay, it's bigger than the object was. Its location is behind the mirror. Okay, its attitude is upright because it's not upside down this time, and its type is virtual. Okay, and so you can use this mirror as a magnifier. Now, if you've ever seen Okay, Vion, what is it? It's a makeup mirror. A makeup mirror. You can put it really close to your face. It's curved and it magnifies your face. Okay, which I find, like, you know, as a 300-year-old man, very disconcerting. Okay, to magnify like all the wrinkles on my face and whatever, and little flaws and imperfections. Okay, as perfect as it is, it's, you know, everyone is their worst judge, right? Their worst critic. But anyway, I mean, some people have a use for these curved mirrors that they put really close to their face. I've seen it like at makeup tables and stuff like that. So like my sister would have one, okay, that she puts her face really close to it. She's like, I don't know what she's doing, drawing on her eye or something like that. Okay, so anyway, you get the idea. So when you have to put your face close to it though, and then you will see through the mirror, you will see a larger magnified view of your face in this curved mirror. And that is an application of these mirrors. It's sort of a useful thing, okay? But you have to put your face close enough, in other words, closer than F. So if you put your face here, somewhere in this area in here, between the focal point and the mirror, so quite close to the mirror, you will see that, okay? And there you have it, my friends. That's how you do this. Now I'm going to ask you to try to do it for these other two that I didn't do with you, okay? And then I want you to fill in this chart, okay? Write down the characteristics of the image, okay? And so you should be able to answer these questions. And I'm going to leave it there for today. That's long enough. So just finish this sheet. It shouldn't take too long since I did like half of it with you, but do the best you can. And then on Friday, we'll take it up together, okay? So you'll need to print the sheet to do the activity properly. So please do that if you can. If you can't, don't worry. I'll give you a chance to do it in class on Friday, but I prefer if you could do it at home because we have another one we're going to look at, okay, on Friday. So have a good day, guys, and I will see you tomorrow. Don't forget, for everyone except Sarah Fota, it is a dress down day, right? Okay, on Friday. I'm just kidding. I know Sarah's going to dress down anyway, but you know, I got to say it because she's had a lot of turns at this. Okay, so guys, listen, have a great day, and I will see you tomorrow. Prepare for the rain tomorrow, eh? It's supposed to rain, heavy rain Friday. Heavy rain Friday, so keep that in mind. All right, good night, or good afternoon.